Hello, my name is William Rose. I'm just doing the post-lab debrief for the module number 3, lab 3 post-lab reflection. So this week it consisted of 2 experiments. The first one, which was the copper gluconate, extracting the copper from the washers and then basically calculating how much actual copper substance there was. So to start off, the safety protocols, same as always: fire extinguisher, the main escape points, garage doors. I had these open while I was doing the experiment, just to allow proper ventilation, and then through the door, the lab wash station. Again, fire extinguisher down there. I had spare nitrile gloves. I had that door open as well. And then I had my dry absorption material there up against the wall. So as far as the lab experiment went, I just kind of finished the labs. I'm going to start doing cleanup after this. Everything went really well. I did all the proper measurements, followed the guidelines and the procedures. The only issue I ran into was the 250 milliliter beaker broke on shipping, so I had to use this 250 millimeter beaker here, which I'm pointing out with the pen, but it worked out perfectly, so all is good. And then basically I started out and I weighed the copper gluconate per the scale, and then basically extracted the copper, dehydrated it, went to weigh the copper extracted material afterwards. And the only issue I ran into was the scale was not precise enough to pick up the actual weight of the copper. It stayed at 0.0 grams. So I annotated that. I took a picture, which I'll upload, but basically when we get to the actual calculation here, finding the molecular weight of copper with 0 actual weighted grams, I could not actually do the calculations. So I made a note basically stating that my post-experiment weight was 0.0 grams. However, for this example, I used 0.1 grams of copper so that I could actually progress through the test procedure. Other than that, as far as the solution on the washers, I went just at 20 minutes, which was the maximum you could go per the instructions. And then basically scraped off all the material, threw it in the oven, let it dehydrate, and then came back and weighed everything. And so after that, basically, like I said, I used the 0.1 grams of copper for the example, and then kind of went through the steps as far as the copper mass divided by the molecular mass of copper. And then I just kind of annotated everything as I go. And so step 1, I had 0.1 grams of copper divided by 63.55 grams per mole of copper, and came up with 0.001574 mole for the copper. And then when we get into step 2, I subtract my copper weight from the copper gluconate. I came up with 0.9 grams of gluconate. I'm sure I'm pronouncing that wrong. And then calculated the molecular weight of that, which was 0.004588 mole. And then to find the ratio, I basically took the higher value, divided it by the lower value, which was copper. Came up with 2.91567 as my ratio, and roughly rounded to 1 to 3. So 1 part copper to 3 parts gluconate. And then that was pretty much it for experiment 1. So when we get down a little lower, we go to experiment 2. And that one was doing the sodium chloride, the stearic acid, the sucrose, and then applying heat for a maximum of 5 minutes, calculating the time it took for them to go from a solid to a liquid. And basically, to start off, my hypothesis was kind of the stronger the bond, the more resistive it would be to a chemical, like a state change, which shows to be pretty evident. When we get into the stearic acid, that one actually took 34.96 seconds to melt, and predicted bond type was a covalent bond type. I put a couple more things to help identify the bond type and the specific properties. So we'll just go through them all real quick. Sucrose, that came in at 161.99 seconds, and the sodium chloride did not melt. So sodium chloride was an ionic bond, and which was kind of the strongest bond type. The outer ring for the electrons completed itself based on its bond type. So that one didn't melt, so that kind of proved my hypothesis. The stearic acid was the least amount of time. It was a nonpolar, single, covalent. It had a similar electronegativity value. And then sucrose, 161.99, polar, covalent, had less electronegativity, which these kind of came about from finding the chemical makeup of the substance and then finding their relation of their electronegativity. Ones that were less electronegative were polar, and similar was nonpolar. And so basically it goes in to validate my hypothesis when we get to nonpolar, which would be kind of the weakest bond. We had the least amount of time. Then we go polar, a little bit more time. Ionic bond did not melt. So overall, pretty happy with those results. As far as procedures and everything go for the lab, the only thing, like I said, the issue I had was the scale was not precise enough. It went it went to 1/10 of a gram, and my copper just did not or would not hit that 0.1 grams. I think it had to be right there. I know it said it had a limitation on the chemical and the heat for the washer. I was still getting a little bit of reaction from the chemical and the washer. So given a little more time, maybe I could have gotten a little bit more extracted from that. But we had some rock salt, and so I tried to use some of the rock salt to figure out exactly how far I was off. And I was basically going to try to quantify the specific value to come up with something a little bit more precise. But my scale tended to go from 0 to 0.3 grams and never would really hit the 0.1 to 0.2. I tried to use a couple different weighted papers, and I even went into the recalibration of the scale, but I don't have a 500 gram calibrated weight, so I couldn't really recalibrate it. So I kind of have to take that for what it is. Other than that, minor deviation, I used a little blowtorch instead of the matches, but that negligible effect. And then everything else is kind of set up here. Like I said, I'm going to clean now after this reflection, but overall, very successful experimentation. And I have the kind of the guidance here, so I was just kind of going over that, make sure I covered everything. Yeah, so overall, I think everything was a success. So thank you.